Yes.
Yeah, good morning guys. Let us get started. So today we are going to discuss about the questions, whatever we discussed so far in last around 17 days. Okay. Now can someone tell me what is a thread? What's the definition of a thread? Quickly. Anyone?
Independent path of execution.
Yeah. It is an independent path of execution within a program. So if you want to debug it, what is the prerequisite? You need to keep the breakpoint in the run method, then only you can see, correct? So sometimes it happens that we don't keep a debugger and we say that it is not happening a independent path, right? So whenever you want to debug, you need to keep in brain that breakpoint should be there in the run method, or else thread will start, execute the run method, and it will come back, right? Yeah. How many ways we can create a thread object?
3 ways.
What are those?
Extending thread, implementing runnable, and implementing callable.
Guys, don't worry about the spelling mistakes. I can correct it later. Implementing callable. What are the different states in thread?
New, runnable, running, dead.
And blocked whenever it is going on sleep and wait. So when can I call a new, thread is in a new state?
When we are going to create the thread.
And
before starting the thread.
Yeah, before calling the start method.
Before calling the start.
Yeah, when can we say that it's a runnable?
Thread.start. Then it will go to runnable pull.
Okay. When it is running?
When start method calling the run method, then it is in the running method, running state.
So from the runnable pool, scheduler will pick a thread based on the thread priority and some other factors, and then it will give the opportunity to run method. So whenever any thread that is executing the run method is called as a running state. What is thread?
So it's completed the run method execution, so thread will be considered as a dead.
Okay. What is blocked? So whenever we call sorry, go ahead. Yeah, go ahead.
Yeah, when the thread is in sleep mode or waiting mode.
Yeah. So whenever we call a sleep method or wait method, the thread will go to the wait mode. So that means it will it is blocked for the execution, right? So that's a blocked thread. What happens when we call the start on a dead thread?
Illegal thread state exception.
Yeah, illegal thread state exception. How does it know? We are calling the
thread status by using the variable thread status.
By using the variable called thread status. So first time when we call,
count will be 0.
Start method thread status value is 0, and it gets set to some non-zero value, correct? Immediately value after starting the independent path. So next time when we call the start, the thread, the variable value is no longer non-zero number, and it throws exception, correct? Yeah, I think this has come twice. This. Yeah. Okay. So this can be asked. The question can be asked in a different way. Can we call the start method on a thread twice? No.
No.
Same answer as above. Okay. What is the thread flow of execution start? Where the thread flow of execution start?
Thread start run.
Run method run method or call method, correct? If it's a run, if I'm implementing a runnable interface or extending a thread class, the thread flow of execution starts from run method. If I'm implementing a callable interface, then thread flow of execution starts from call method.
Call
correct?
method.
Yeah. So how to set a priority to a set thread? Using set priority. So there is a method called, we have a set name method, right? Similarly, we have a set priority method. This, the priority varies from 1 to 10. Okay. So 1 is main priority. 10 is max priority. And 5 is non-priority. So what is the main thread priority? Main thread priority is 5. So whenever you set a priority, immediately it does not mean that it will take that thread. So so whenever, now, when the thread is in the runnable pool, operating system or scheduler will pick the thread and it will start giving the opportunity to execute run method. So at that time, one of the things that the scheduler will consider is priority. But if I say that if a thread has a priority as 10, it will guarantee execute? No, I cannot say. So one parameter that the scheduler will look at is set priority method. Like what is the priority of a thread? Even though priority is high, it does not mean that immediately that will get executed. So it is one of the parameter. Okay. How to set a name to a thread? Set name or thread constructor. Yeah. Okay. What is the join method of a thread?
Join method allows one thread to wait for another thread to complete the execution.
Work can be continued only after a specific thread is completed. So for example, so if I am saying that in the main method, if I am saying that if there is a code t1.start, t1.join, sys out. So which thread will go into a wait mode after join means which thread will wait in this scenario?
Main thread.
Yeah, main thread. That means the thread which has created another thread will wait. Main thread will wait for T1 to complete. Okay. Now, for example, now what I will do here, instead of main thread, can I create a thread in some other method, correct? So I have a main method. Okay. From main method, I will say T1 dot start. So I will, when I say T1 dot start, where I will go? Or else let me write thread T equal to new thread. I will write new runnable. What am I doing, guys, here? Am I writing anonymous in a class?
Yes.
Yeah. So I'm overriding public void run. Now, can I say, if I say here t dot start, what happens? Can I say this thread will start executing? Yes. Now in the run method, can I create some other thread?
Yes.
Can I create one more thread in the run method? I can, correct? So
Yes.
create some other thread. Okay. Now when I say some other thread means assume that there is a class, there is a separate class called thread extend class thread extends runnable. Sorry, implements. So now here I have created a thread. So that is nothing but this one. Okay. Now t dot start that is I'm taking it as an object as t2 dot start, and I will say t2 dot join. Now which thread will wait, guys, to complete? Do you guys understand what is my question?
T1 thread.
Yeah. So this, whatever the thread, this one is there, right? This will
Yeah.
wait, correct? This now here T thread will wait for T2 thread to complete the work, correct? Am I right? It is not always main thread. Whichever the thread that is starting, it will wait, correct?
Yes.
Yeah. Okay. No, I have just written the high level program, guys. You can do this one.
Sir,
I will. Yeah.
Instead of work, we can write thread, make sure that work can be continued.
Instead of
Work, can we say a thread?
Yeah.
A thread can be continued only after another thread is completed.
Yeah. Yes, correct. Yeah. So thread T2 equal to new thread, and then I will say new thread example, correct? Yeah. Okay. So you can complete this guys program. Now, what is the difference between sleep and wait? Quickly, I will refer to the notes. Okay.
Sleep method will not release the lock.
Sleep
Wait
method present in the
will
thread
release.
class and the wait method present in the object class. And sleep will not release the lock and wait will release the lock on the object.
Sleep doesn't require the lock as well. It will be timed out after a specified time.
Okay. What else?
And wait method is part of object class.
Okay. What else?
Sleep method will like synchronization block we cannot use the sleep where wait we can use. We have to use the synchronization block.
Yeah. So wait, notify all should be used within a synchronized block. Sleep should be within a synchronized block or without a synchronized block, correct? Now, and so if I have to demonstrate that it should be in a synchronized block, how can I write a program for wait? So you create two threads. Two threads should have a constructor and taking an object. And from the main method, you have to pass the same object. Then it will acquire the object lock, correct? Even though the methods are different, you are passing the same object. That means multiple threads are working on same object, right? So what is inter-thread communication? Anyone? What is inter-thread communication? And which method does the inter-thread communication?
Wait, notify all. So it will communicate internally.
Okay. So one example. How can I write? How can I demonstrate that inter-thread communication is happening using programming?
Wait and notify.
Yes, I want, for example, if I'm interviewer, I ask you to write a program for inter-thread communication. What do you write?
If T1 thread, in the T1 thread, if you call the wait method, it will automatically give the priority to, it will release the lock and on synchronized thread, and it is giving to other thread to execute, give the chance.
Yeah. So you need to tell.
If you call the notify method, then it will again continue the wherever the wait method we called there. From there,
yeah,
it will be.
Yeah, you can say that T1 is one thread, okay, and it is working on object A, okay, and it is executing what method? Some M1 method, and M1 it is executing M1 synchronized method, okay, and inside the so can I say that it will acquire the lock? Okay, and once, and if we have wait method inside synchronized block, then what happens? It will release the lock, correct? Am I right?
Yes, sir.
Okay. So look at the program that we have written. So we have written a bank example. In the withdraw method, since the balance is low, I have released the lock. In order to release the lock, what is the method I have called? Wait method. So I'm telling T1 thread is working on A object and executing M1 synchronized method. Can I say that whenever it is accessing, so can I say it will acquire the object lock on A?
Yes.
On object lock on A. Done. And if we have a wait method inside the signals block, it will release the lock, correct? Now at the same time, T2 is trying to work. It is T2 also trying to work on A and different synchronized method called M2. Then what happens? Because of the object lock, first this method will not work, correct? And it will wake it will, because of object lock on A, T1 will wait and it will execute only after wait method has released the lock. Am I right? Okay. Now again, let us take T3 method. Okay. Now T3 method is also executing. T3 method is working on an object called B, and it is acquiring. It is calling the M1 synchronized method. Okay. See, A, B, all the objects are same class only. Now, can I say that here also what happens? Whenever it is executing M3 synchronized method, can I say it will acquire the object lock on B, correct?
Yes.
Yeah. Okay. Now, so now here, now can I say that here, since this wait method is release the lock and M2 method is also what it's doing, it also has a wait method. Then T2 will go to wait mode, correct? Okay. Now what I wanted to say is, how many threads are waiting on A thread currently?
2 threads.
And how many threads are waiting on B object?
1.
Okay. Now whenever I say from T4 using the T4 thread, T4 thread is working on A object and it is saying notify. Then which thread will come back to the execution?
Either T2 or T1.
So here T4 thread is working on A object and the different synchronized method. Whenever it says notify, when it says notify, T1 or T2 will come back to execution, correct? Anyone, right?
Yes.
Any one of T1 or T2 will come back to execution. Okay. Now, if I say notify all, whereas notify all, what happens? T1 and T2 both will come back to the execution, right?
Yes.
Why not T3 will not come back?
T3 is on another object.
Yeah. T3 will not come back because it has lock on B object and not A. Now in this example, so this is what the example that we have done, right? ABC thread, ATM thread, net banking thread. ATM and net bank is working on a Karthik account. ABC thread is acquiring some other lock and a different object. So it did not come back to. So here in this scenario, when T4 thread is executing or saying notify or notify all, what it is telling? It is talking to other T1 and T2 threads which are working on the same object, and it is telling that, hey, T1 and T2 come back to the execution. So can I say that this is an inter-thread communication?
Yes.
Yeah. So now how can you make sure that T1 is working on A, T2 is working on A, T3 is working on B, T4 is working on A? How can you say this? So if you are using a standard thread class, you can in this class, in the threads, so T1, T2, T3, T4, for all these objects, you should have created a thread class, right? And extended a runnable or implementing runnable or extending a thread class. So you need to create a constructor. From the main method, pass the same object. Am I right?
Yes.
Yeah. Others, are you able to understand? Everyone?
Yes.
Yeah.
Yes.
Yes, sir.
Now. So why wait if wait, notify, notify are present in object class?
Because
Intercommunication.
lock can be acquired on object, and object is the superclass of all the classes.
Lock is acquired on object, not on thread, and not on method, correct? So one thread should tell another thread to come back to execution. So this is only possible if the methods are in object class. Because object is parent for all, correct? Am I right? Is this the reason?
Yes.
Okay. So what is synchronization? So I can say that synchronization is nothing but when T1 thread is working on a object and it is executing M1 method, and if T2 thread is there and it is also working on A, then it should not give the access to M2 method, correct? No access. If we give the access, the problem is, I mean, like the deposit and withdraw that we have tried. So your output might be different, correct? If the transactions are happening at the same time on a same object, you need to provide, even if it is happening same time, you need some mechanism that if it is accessing one method on the same object, other method should not give you the access. So in order to provide you this kind of a flexibility, we go for a synchronization. So how can you provide a synchronization using synchronized keyword?
So synchronization, nothing but acquiring the locks.
Yeah. Yes, it can be a class lock or it can be an object lock.
Yeah.
Okay. Now, what is an object lock and what is a class lock? So this question, they don't ask you guys, what is the object lock, what is the class lock directly. They will give you the scenario like T1 is working on, so now instead of writing, I will draw here. Let me make it as little big. So T1 is one thread and it is working on, okay. So in the interview, I have seen many people asking this question and they ask you in the way that, okay, no. So T1 is one thread and it is working M1 method on A object. Can T2 work M2 method on the same object?
No.
If it is not synchronized, yes.
Yes,
Yeah.
works. Okay. If M1 and M2 are not synchronized. So you need to answer like this. They are expecting, you should ask that question, right? So that means you should have a knowledge whether M1 and M2 are synchronized or not, correct? That means whether the lock is acquiring or not depends on a synchronized keyword. Am I right? Now, the same example, then they will change it like, now T1 is working on A object M1 and T2 is working on M2. Both are synchronized. Then can T2 able to access any other method?
No.
M1 or M2 or etc. No, this is object lock, correct? And object lock on A, correct? Now,
Yeah.
now same question they will be asking another one. So this is a object lock example, right? Now, so in the object lock, what M1, M2, M3 methods are? What kind of a methods?
Instance
Instance
method.
method.
M1, M2, and M3 are instance methods. Now T1 is working on reference of A. So here test is class and A is object. They don't give you like this. So they'll say, just say that A object. Now T1 is working on test class and executing M1 method. T2 is working on test class and executing M2 method. Will it work? It will work as long as M1 and M2 are not synchronized, correct?
Yes.
So you should never forget that asking that question. Okay, not synchronized. For example, if it is synchronized, now again same T1, T2, and test class M1, and it can be M2, M3, M4. Can it work on the
If it is
same reference?
synchronized,
No, on the same class reference, it will not. So can I say that here class lock on test? So what can be M1, M2, M3 methods?
Static methods.
Static methods.
Okay. Now that means what kind of a data you will make thread safe in the object lock? In the object lock, what kind of a data will be thread safe?
Synchronized data.
No. Instance data, correct?
Instance data.
Instance variables will be thread safe, correct? And in class lock, static variables will be
thread safe.
Okay. So this is what we have discussed around 3 to 4 days, correct? So whatever we have discussed for 3 to 4 days, can I say that is entire there in this diagram?
Yes.
So they will be asking the questions like this. Okay. Any questions on this so far? Anyone?
No.
So the same question I have written here. T1 is working on M1 synchronized method on A object. Can T2 execute M2 synchronized method on A object? Answer is no. Because of object lock on A. Understanding this object lock and class lock is very important. If you understand this only, then multi-threading, cyclic barrier, all semaphore, all those you can understand, correct? Yeah. So what is the disadvantage of general way of creating a thread?
Thread cannot be restarted again once completed. Its
Thread
task.
cannot be
reused,
restarted, or reused, correct? Yeah. What kind of data we can make thread safe using a class lock?
static data.
Static
data or static variables of class. Okay. What is thread pool?
Collection of threads.
Yeah, pool of threads or collection of threads. Okay. Why do we go for this?
Reusing the threads.
overcome the thread
Disadvantage
of thread.
of general thread creation. Okay. How many thread pools are present in Java? 4.
4.
Fixed. Can I say that refer to notes instead of writing? Yeah, fixed thread pool, cached thread pool, single thread pool, schedule thread pool.
Schedule this.
So how the thread will take the work from the thread pool?
Internally, CPU will allocate the thread.
Okay. What else? Anyone? How the thread will take the work from thread pool?
Using executor framework.
Using executor framework, you will implement the thread pool. But once I have written an executor framework, executors.new fixed thread pool equal to 3, and I will write a for loop. So 3 threads will started, and then 3 threads after completion of 1 thread, that thread has to, if there is a work, it has to take. From where it will take?
From queue.
Yeah, internally, the thread pool uses the queue concept, correct? Queue, and all the threads will take the work or task from the queue. What is it meant by a task here? Whatever you want to do the work for each and every thread, correct? That is nothing but a task. Now in our example in the multi-threading, triggering a email is a task, or salary calculation is a task. So that task you wanted to execute for 1,000 employees. Yes. And and at the same time, you don't want to do time. So what you are doing, you are creating a 3 threads, and those 3 threads are executing the salary calculation logic for 1,000 employees. So first 3 threads will take the 3 employees and then do the salary calculation. After completion of that, each thread will take the different employee from the queue and it will execute salary calculation logic, which is present under the run method. Am I right?
Yes.
Yeah. So why are we going for callable interface?
If
To
we
get the
want to
return
return
object.
some values from the run method.
From runnable, we cannot return the value. So we go for callable interface. Using callable, a value can be returned from thread, correct? Done. So what is the abstract method present in a callable?
Call method.
Okay. And so whatever the generics that you pass, that call method will return the same thing. Is the thread platform dependent or independent?
Platform independent.
How can, if it is a independent, then it is like a Java, right? You can decide. It is a dependent, right?
No,
It
threads are dependent.
It is depending on your operating, so your OS, right? So if you are having a very own one single core processor, and is that same as 10 core processor? No, correct?
Yes.
So the thread is platform dependent, because whenever I say, if you remember, every time I am telling which thread is executing, can we guess it? It is not. It is depending on operating system. So when I say it is operating system, so Linux will have different implementation, and Microsoft will have different, and Ubuntu will have different, right? So thread is a platform dependent. Okay. What are the different? This is done already. Okay. Now, what is the difference between thread and then runnable interface in Java? So I'll come to this one. This we need a discussion. So let me keep this for tomorrow. Okay, I am keeping in yellow. Now let us complete the remove. What is a semaphore?
This is a synchronization mechanism which allows fixed number of threads.
Okay. So how it is different
Different
from
number of
normal synchronization?
Here we can define the number of threads by using semaphore class, so that whatever we define, it will allow only those number of threads. So we have more threads. Let's say we have some 5 threads we defined. We are running 5 threads. In semaphore, we have defined only some 2 threads. So though we have 5 threads running, it will allow only 2 threads in the semaphore different block. I mean, yeah.
We
So-
can limit the thread execution.
Yeah. So in general way, if we create 5 threads and working on 5 different objects, can I say 5 threads we can work independently?
Yes.
Threads will start executing on 5 objects and work parallelly, correct? Okay. So here, but I want to limit the limit to only 2 threads. Then what should I do? Then I can go for a semaphore. In the semaphore, we have, whenever you are creating an object for semaphore class, you need to pass permits. So you want to execute only 2 threads at a time. Then what you can do in the semaphore object creation, you have to pass 2. After that, whichever the code that you want to execute 2 threads, you have to write that code in the semaphore.acquire, I mean like object.acquire, object.release. Between the acquire and then release method, you have to work. So wherever you are writing acquire and release, the semaphore will make sure that only that whatever the number of formats you have given, that many number of threads only executing. Am I right?
Yes.
Okay. Now, what is a race condition? A race condition is nothing but, so whenever, so here, if I am not using a synchronization keyword, what happens? In the banking example, if I'm not using synchronized keyword and I'm trying to do the deposit and withdraw at the same time,
Inconsistent results.
yes, that is nothing but a race condition. So now I'll whatever the notes I will be sharing, I have mentioned. So a race condition in Java is a bug occurs in multiple thread access, shared resource or variable simultaneously. So in the example that we have written, withdraw method and deposit method, if I am not putting a synchronized keyword, can I say that both the threads are able to see my balance as same, correct? Balance is a variable, it's a shared value, correct? Between those two threads. And if I am not keeping a synchronized keyword, multiple threads can execute different methods on the same object. Can I say that will lead to my either my balance may be positive or balance may be negative, correct? It will be what you call loss for the bank or loss for the customer at the same time, right? Or benefit for the bank or benefit for the customer. So that means the variable value cannot be proper. Am I right?
Yes.
So the same example we have seen in the yesterday, whenever we are using atomic integer, we have created one variable and we are trying to increment the count without using a synchronized block. Can I say that my count sometimes 2000 or sometimes 1760 or 1100 or something, correct? So can I say that is a shared value? It is getting modified. So that itself is nothing but a race condition. So the race condition in Java occurs when multiple threads access the shared resource or variable simultaneously, leading to unpredictable or inconsistent behavior. Okay. Now, how can I avoid this race condition? Using synchronization mechanism. That means you synchronized method or synchronized keyword or atomic operation like atomic integer, or what you can do, can I say that lock mechanism also? Correct. Synchronization and locking both are same, correct? Now, atomic operations, or instead of what you will use, instead of using a normal variable, you can go for atomic integer, atomic long, etc. Or else, so if instead of using array list and all, you can use concurrent hash map, copy and write array list, because they internally has a like at segment level locking. So the race condition is nothing but whatever we have seen in the yesterday class. Whenever I execute the program, the output is inconsistent, right? That itself is a race condition. So to avoid race condition, we go for synchronization. We can go for a synchronization, or we can go for a locking mechanism, or we can use a atomic variables. I'll just refer to notes. Okay. Any questions on this case? What is a race? I have explained this one because you already know the answer, but you do not know the question here, correct? What is a race condition? Yes, no?
Yes, Karthik.
Yeah. So what is join method and how it is different from countdown latch?
For a single thread join method, and if there are pool of threads, then countdown latch.
Yeah. So join method makes sure that single thread is completed, correct? But countdown latch makes sure that all the threads in a pool have completed the executing all the tasks present in the queue. Can I say this one? So if I have to use a countdown latch, how should I use? I have to create a class object for countdown latch, and then whatever the number of tasks you want to execute, you initialize with that. Okay. And whenever you are completing, each thread will execute run method. So in that run method, what you do? Countdown. The latch object dot countdown. That means every time you are reducing the count. And in main method, what you need to do? Latch dot await. You need to call await method, so that whenever the countdown becomes 0, then lock will be released. Shall I show the program? Yes, am I audible?
Yes, sir.
Yes, Karthik.
Yeah. So if you look at here, so why did I see here? I have created 3 threads. Am I keeping 3 countdown latch to 3 or should I keep it to 10? See, 3 threads have created. What does a for loop means? 3, I want to execute 10 tasks, correct? So, or for example, I want to execute a salary calculation. Yes, how many on whenever you say salary calculation, it will be employee or it will be some department, something, correct? So, how many percent salary calculation I want to do here? 10. That means you are doing the 10 tasks. In order to complete the 10 tasks, how many threads you are using? 3 threads, correct? So each thread will take one task first. After completion of these 3 threads, 3 tasks, and then those will take another task from the queue. So when can you say that all the threads have completed all the work? So whenever you are so that's the reason I have given the countdown latch to 10, which is nothing but number of tasks. And after completion of each thread will execute run method only, correct? So after completion of that each method, at the end I have written countdown. The first 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Whenever the countdown 0, then the await method will release the lock of a main method. So whenever you are executing this program, your main method is a separate process and this thread is a separate process. So what you can do, you may go to the main method and then execute the line number 26. From line number 26, it will go into a wait mode because by the time this thread is not completed. Once you complete all the threads, whenever the countdown becomes 0, then your main thread will come back to the execution. Correct? If I don't keep like this, it will, if I comment this line, it will execute, right? If I don't comment this line, it will continue. Is this right? Yes. Am I audible?
Yes, Karthik.
Yeah. Any doubts on this, anyone? Okay. So now what is a daemon thread, which I did not tell you? What is a daemon thread?
Background thread is a daemon thread.
Yeah. Yeah. Background execution thread is called as daemon thread. What is a background execution thread example?
Garbage collector.
Yeah. How to trigger a garbage collector?
Runtime.gc.
Runtime.get runtime gc or system.gc. Now let me quickly show you that daemon thread example. Okay. We can make user defined thread also daemon thread. Okay. Now here guys, now I am writing a main method. Now in the main method, what I'm doing, I want to create this object. Okay. Daemon thread t equal to new daemon thread. Okay. Now, whenever I make t equal to null, can I say that first I created an object. So in the object, so whenever I create a line number 7 daemon thread example t equal to new daemon thread example, can I say in the memory it will be happening like this? I think if you see this is a heap memory, it acquired the lock and it is referred by the t, correct? Am I right?
Yes.
Okay. Now whenever I in line number 8, whenever I say t equal to null, so currently can I say this is a referenced object?
Yes.
It is referenced by t. Now if I say t equal to null, can I say this reference is gone?
Yes.
So the memory still is there, but it is not referenced anything by the program. So then after some time, the garbage collection runs. So we have a system.out.println. In that, what is a system? System is a class, correct? So there is a method called GC. What is a method? See, I'm calling a GC, this one, see anything followed by name and the parenthesis is nothing but a method. So GC is a method. And I'm calling this method with a class name. What does it mean? What kind of a method it is?
Static method.
Static method, correct? Yeah. So there is a method called system.gc. This directly will not ignore a garbage collection. What it will do is it will request Java to run the garbage collection. Whenever the garbage collection runs, it will execute the finalize method. Okay, now let me keep finalize method. Now let me show you. Hi. Now let me keep a debugger. Now I am trying to tell you that garbage collection, what is a daemon thread? Background execution thread is called as a garbage daemon thread. Now, whenever I say sys, do you trigger a garbage collector in your program or in your project? Whenever the garbage collection threads runs automatically, correct? And every certain amount of time it will run, and it will delete the memory for unreferenced objects in the entire program, correct? So that your heap memory will not be, you will not get an out of memory error. Am I right?
Yes.
So you don't need to trigger separately, correct? So it runs in the background. So those background threads are called daemon thread. But in order to show you that, see, now in this program, t equal to null, I cannot guarantee that immediately the garbage collection will run or not. So I'm putting a request to the garbage collection by using this method. And whenever I debug, I will show you what is why the garbage collection is called as a daemon thread. See, whenever I say system.gc will put a request to the garbage collection. Garbage collection is a daemon thread. So whether it's a daemon thread or any thread, what is a thread? It's an independent path. Can you see one more execution should create? Look at here. Can I say one more execution is started? And whenever your garbage collection is executing, it will execute the finalize method on the corresponding object. In this example, which object I'm garbage collecting?
Daemon thread example.
Daemon thread example object, that object name is T. Now, in this, so whichever the object you are garbage collecting, it will go to that class finalize method. Now see, thread is one. Can you say that another thread is executing and the finalize method? Yes. Now what do you see? What kind of a thread it is? Daemon system thread, correct? So in order to show you this daemon system thread, so the garbage collection is one example of a daemon thread. Okay. Now the question comes, sir, how can I make my user defined thread as a garbage collection, daemon thread? So here, for example, daemon thread extends thread. Okay. Now you want to, can I say now this is a thread object? No. Yes. Now if you want to make this thread object is a background execution thread, you don't want to execute normally, you want to make it as a background. Then what do? You have to make it as a daemon. So set daemon. So there is a method called set daemon. By using this method and passing true, you will make your user defined thread as a background execution thread. So makes the thread as either daemon thread or user thread. The virtual machine exists when only the threads running all the daemon threads. Okay. The method must invoked before the thread is started. Correct? So set daemon method will make sure that your user defined thread is daemon thread or not. Any questions? Does it understood?
Yes.
Okay. Now what is a countdown latch? Just now we have discussed, right? We don't need. So cyclic barrier, I did not tell you. I will tell you tomorrow. Okay. So this will.
Why we need to create daemon thread? I mean, the scenario.
You don't need to create. I'm just telling. So for example, virtual garbage collection is a daemon thread, correct? So it executes in the background automatically, right? If you see, generally we don't create the user defined thread as a daemon thread, but if there is a requirement to create it, or you want to execute one thread in the background due to some your business scenario or functional scenario, then how can you do? The question comes, can't I do my normal thread as a daemon thread? That question comes, right? So in order to make your thread as a daemon thread, you have to use this set daemon method.
Sir, it's not necessary that the daemon thread will be doing the work of garbage collector. We can define it in a user way.
Yeah. So yes, see one example of a daemon thread is garbage collection. Okay. So do you trigger a garbage collection in your project?
No.
No, automatically the garbage collection is happening. Do you aware of it? Now,
yes.
Let me show you task manager. In the task manager, see, you can see how many applications are running in mine. Edge browser, Google Chrome, Eclipse, OneNote, Google and Zoom. and this outlook something, correct? But see, if you look at the details, how many processes are running? Look at here, correct? So can I say some are running in the background? In order to make your Eclipse, some other process will run in the background. Am I right? Similarly, so in order for you to create, not to get a out of memory error, garbage. So you don't need to tell if for example, garbage collection is in your hands. So you might forget to tell the JVM that please run the garbage collection, right? Then your application will go into out of memory. So JVM will decide when to run the garbage collection thread. So that is one example is like the garbage collection thread. So it will free up the memory, right? So, but if there is a requirement that you want to create a thread and it has to be working in the background, then how can you make that thread as a working in a background? By calling the setDemon method. But generally we don't do that. Is that understood?
Yes.
The one who asked it
Yes.
earlier? No, not you, before that, one person.
Yes. Yes.
Yeah, thanks. So what is a volatile variable and why it is useful in the multithreading? Volatile will resolve visibility issues, correct?
Yes.
So one thread cannot see what is happening. One thread cannot see what is happening in another thread. Suppose if both the threads are using the same variable, then the value
keep on
may
changing.
not be updated properly because threads are independent, correct?
Yes.
Okay. Now, so if I make that variable as a volatile, then immediately the value will be pushed to the main cache from the thread cache, correct? So refer the notes for more information. Okay. Volatile is applicable for method or variable?
Variable.
Variable. Yeah, don't worry about this spelling mistakes. I'll correct it later. I'm not very much good at typing fastly. Yeah, what is a thread local variable and how does it work? Now, thread local variable, see here. So now in the yesterday program, so what is a local variable, guys?
Count variable.
What is a local variable? So here, can I, in this one, if I create in this one int I equal to 10. So what is the meaning? I is a local variable. And what is the accessibility of this local variable?
Within that method.
Only within that method. Yeah. Now, if I call the run method, now from the run method, so I say whenever I'm creating a thread, the thread will start run method. From the run method, can I call some other method also? My user defined method, yes or no? Yes, correct. Any method I can call, right? Instead of writing the entire C, if I want to execute whenever I'm doing the multi-threading, the thread will start from run method. And if I want to execute some code of 1,000 lines, can I directly write that 1,000 lines in the run method? That is not the good way. Your code should be modularized. So that means I will create multiple methods and then I will reuse it. Now this method I will call here. Okay. Now, for example, if in the run method, if I create int I equal to 10, can I access this I in this one?
No.
No. That means local variable is for method only. So, but when I say whenever your thread is running the run method, can I say it can execute the display method also?
Yes.
Now, so when can I say that the thread is completed the work?
Once run method is complete.
So run method is completed, but internally run is calling display. Now, can I create one more method called M1?
Yes.
Yeah. So if I keep M1 method, so here, can I say that I want to, you see here, the thread can be completed only when display is completed, M1 is completed, correct?
Yes.
Now I want a variable to be used in the run method, in the display method, in the M1 method. Is it possible in Java to create a variable which can be
Yes.
used only in these three methods? What is
Yes.
that?
We have to pass the method parameter.
So method parameter, if you pass, that is also, it becomes a local, right? It will not be a global. Am I right?
Yes, it is local.
Yes, local.
So I want to use one variable across the three methods or across only. See, whenever you start a thread, the thread can execute run method. Within the run method, you can call 100 methods. So till the last line of a thread execution or till the completion of a run method, I want to have one variable. Correct? Can I use it? Local variable?
No.
No. So that's where the thread local comes into picture. Thread local is a class in Java. So that variable is common for a thread. Now let me. So do you understand the difference between a local variable now? So that means, see, you don't worry about thread local, I'll tell you. But if I have to have a local variable for a thread, the Java local variable inside whatever you're writing inside a method, that will not solve the problem. Am I right? Because if I create a variable inside a run method, the scope is for run method only. That cannot be accessed in the display. Am I right? If I create a variable in the display, can I access in the M1? No. My requirement is throughout the run method, I can call 1 method, 2 method, 10 methods, 20 methods. Throughout that completion of a run method, or that means throughout the completion of the thread, I want to use one variable. Is it possible in Java? That means I want to create a variable for a local to a thread. Can I do it? Guys, please respond. I would not be knowing whether you understood it or not.
Yes, correct.
Do you guys understand the problem with the normal local variable? Everyone? I see only one response.
Yes. Local
Yes.
variable we understand.
Yeah. So that means I need some variable which can be used throughout the thread, correct? That means till the completion of a thread. That means I will create one thread, that variable, another thread, another variable, correct? Now, so let's use that. Now here, let me create a thread t equal to new thread, new runnable. So can I say here thread? So now what I will do is I will create a thread local object. Now let me create thread local. I'm creating a thread local, sorry. So there is a class called thread local. See, thread local in the java.lang package, and you need to give the generics, integer, double, anything. T thread. I'm just giving the variable name as a thread local, new thread local. I just created an object. Now let me make it as a static because I'm using in the main method. So now for this, now can I say that T is a thread? Guys, now in the T thread, I want to set the value to using set method 10. Okay. Now in the different thread, I will set the value to differently. Okay. Now let me create one more thread. The one thread is done. Okay. Now if I see in this thread, I want to keep the 20. Now let me start the value. Let me start the threads. T1 dot start, T dot start, T dot start, T1 dot start. Okay. Now let us run the program.
Yeah, but if it is static, it will become a global, right?
No, that is what there is static. See here I have made it as a static because from the main method I'm creating a normal thread. If you're creating a separate thread classes, you can create a separate variable, right? Global variable, instance variable.
Yeah.
Hope you get it. Correct?
Correct.
See, here I have created a threads in such a way that inside a main method. So if I'm not making this as a non-static, can I access it inside a main method? No.
No.
If you are creating a separate threads, so that means you create a separate class called thread, implement runnable, and then override the run method. At that time, do you need to create a static variable? No, there you don't have separately. You are writing a main method, right? See, I mean, different ways of writing a program. That's the only thing.
Okay.
Correct. Now, if I run the program, run as Java application, say 1020, it's a different, correct? Now let us call. Let me create a. Now, what you might be thinking here, right? So here I have written a static variable, but what I am saying is, if I am creating a thread like this, thread local, so I just created this thread local example one, extends thread. Okay. Override run method. I'm just creating thread local, integer, thread L equal to new thread local. Now here, I'm using dot set. So do I need to make, say, am I making mandate here? I think Abdul, right?
Yeah, right.
So different way of, so there, I see here, so can I access this one here? Throughout the
Yes.
threads, you can access it, right?
Correct. Okay.
20. Now after completion, if I call the display and then sys out, now let me call the main method and create a thread and then start it.
Otherwise, also that is an instance variable, object level variable, so we can use it for different methods, right?
Yeah, but you need a synchronization problem, right? If you're using a global variable across multiple threads, that is what we have done for the balance variable, right? In the HDFC bank, we have a balance variable. That's a global variable that we are used in a multiple different methods and different threads. So there is a problem of concurrency. So then you have to use the atomic variable, correct? Or if you want to see, sometimes for just one variable, you cannot do the synchronization because synchronization makes the time, correct? But at the same time, you don't want to do the atomicity. So you want to have a separate copy of each thread. Then you can go for a thread local.
Oh, this is more like atomic.
I mean, like thread level. So you don't want to atomic. You don't want synchronization. I want to do thread side. Like I want to do some calculation inside a thread and then print it. Correct?
Okay, got it.
Yeah. Local. See, why do you go for a local variable? Only for that method, right? So local variable for a thread is nothing but thread local. Okay. Now let us run the program. Run as Java application. See, 20 is coming. See here, look at, if I am using a variable, if I create a local variable in the run method, the scope is in one only. If I modify in the different method, can that variable value will be modified? No. But if it is a thread local, so throughout this thread, this can be used. Now, for example, you will ask, sir, I want to add some data. Now thread local dot get, it will give you integer I. Can't you add the value? I plus 10 or I plus 100. Okay. Now, then what you can do? Thread local dot set. Again, you can call I plus 100. Correct. That means I can perform the operations also. Right. Now, and then I will print. I can do this one. So throughout the thread, I can use this variable and I can modify the value. And this is only for this thread. If you create another thread, this variable will not be. Look at here. So this is about a thread local. Thread local is nothing but having a local variable for a thread. Inside say you might be thinking, sir, how it is different from local variable. No, local variable is for method. So thread execution starts from run method, but it does not mean that run is the only method, right? From the run, you can call 100 methods. So local variable will not solve the problem of having a variable throughout a thread, correct? So that's where you want to have a variable only for a thread that other thread cannot see. You don't want to do synchronization and you don't want to perform the atomicity. Atomicity means one variable can be shared among all the threads. Synchronization means one variable can be shared among all the threads. But what is a thread local? It's a local variable for a thread. If that is a requirement, you can go for a thread local. Is it clear?
Sir, if I have created the, as of now, we have created the run method in the single class only. If I created a separate class,
Yeah,
I
separate. That will be separate thread, right? You want to create one more class, correct?
Yes.
Now,
Like,
and in that thread, you want to keep 10,000 and 100, correct?
yes.
Okay. Now, now you in the main method, so you want to start both the threads in a thread. Then now here, in this one, you start this thread. Can you start another thread also?
Yes.
Thread T2. So do you see different values or not? Correct?
Yes. You mean like one thread local variable belonging to only one thread class only?
Yeah,
it's
that is
not
what.
shared.
Yes. Yes.
Okay,
If it is a shared, then see, if you create instead of thread local, if you create a global variable, see, I understand that local variable is only for method. So rule out that concept. Done. Now instead of thread local, if I create a normal global variable like public int I, what is the problem with this? So can I say this int variable can be seen by all the threads? Yes. If one thread is doing the changes, other threads cannot see. In order to solve that, we'll go for a volatile. So it can see. Now, if I'm doing additions and subtraction, the output is not consistent. So I'll go for a synchronized block or I'll go for an atomic variable. So this you can go only when one variable you want to share across the threads. But my requirement is I don't want to share it anything. I want to have one variable only for thread. So then I can go for thread local.
Okay.
Hope you understand, Ganesh?
Yes, sir.
Yeah. So it's a local, as the name itself telling, local variable for a thread. It is a local variable for thread. I have added the nodes I'll be sharing. Okay. So this fork join pool we will discuss. Optimistic lock, pessimistic lock also we'll discuss in tomorrow class. Okay. Now, how can you interrupt a running thread? So just see here, the thread is running, correct? Now, by calling the thread T1 dot interrupt. See, by calling the interrupt method, you can interrupt a thread. See, T2 dot interrupt. Okay. Now, what happens immediately interrupt? Now, you need to see it will, whenever you call interrupt, it does not mean that it will stop. No, it will set it one flag. So whenever interrupt method is called, you want to stop it. You want to see whether the interrupt method is called or not. Then what you need to do here, how can I get a current executing thread? Thread dot current thread dot is interrupted. Correct? Do you see one variable called is interrupted? Yes. So whenever we call a interrupt method on a thread object, what happens? It will not stop the execution. It will set one value called is interrupted. This is interrupted will be set to true only if the interrupt method is called. Now, for example, if your requirement is if the interrupt method is called, then don't execute the process. Then you have to write like this code. If is thread dot current thread dot is interrupted, if it is true, then you need to stop the thread. Interrupt means stop. So then you can call the stop method. If not, you can execute the rest of the logic.
Yeah. So stop is there, sir. And thread.
Yeah, it is there.
Not be harm.
Yeah, stop method is there. Yes, we have a stop method. So I need to get a thread object. How can I get a thread object? Thread dot current thread will give me the thread object, correct? On top of this, I can call the stop method, right? See, thread dot current thread will give you the object. Now let us quickly debug this.
So it got deprecated, right? So,
Yes.
So is it safe to use that one?
Yeah. I mean, like generally, do you stop a thread? We don't use an interrupter. We don't use a stop method. But Ganesh has asked a question how to interrupt a thread and what is an interrupt. So that's the reason I'm explaining.
Can you just write return something like that so that will be stopped?
Can you?
Can you write return?
No, here return. No, return. No. See, if you write a return, you will get a compilation issue, right?
Just return without any value.
If you have a void, can you write a return statement? You will get a compilation issue. Look at here. If you have a return type, then only your return statement can be valid, right?
Return semicolon.
Yeah, we can do, I think. Return.
But here, is this valid one?
Yeah, I think so.
So, see, compilation perspective, okay. But here, if you
basically that will stop the execution of the program.
Okay. Now, I mean, like it is not stopping the process; it is returning from here, right?
No, but it will stop there. It will stop.
No. See here, method then. It will go to the parent class run method, right? See here, whenever you are in the override, in the run, you have a run method, correct? So first it will go here, and then it will come to see. Whenever you say return, can I say this line will be coming, correct? But whenever I say stop, the thread execution will be stopped. That is what I am trying to say.
Yes, sir. You're correct.
Say thread target.run method means it will call you your class run method. After completion of that your class run method, it will come to line number 834. So whenever you say return, I think it will come back here, but it will not stop immediately. So, but whenever I say stop, the method, the thread execution will be stopped. So, but whenever we say, whenever you say that interrupt, it does not mean that it will stop the thread immediately. So it will set the value to interrupt. So it will set the value internally. So we need to make sure that each interrupted is called or not. How can you make sure? By calling each interrupted method on the current thread. Then it will give you true or false. If it is true, then you can do whatever you want to. Generally, interrupt is called. Then you can do the stop or you can do some other logic, something, correct? So we don't call the stop method. We don't call the interrupt method in the real-time applications. But since the question is asked, I am explaining. Ganesh, does that answer?
Yes, sir.
So if it is stopped there, then how we can restart?
No, there is no restart. That is a problem. That is the reason the stop method is deprecated. See, you should never stop its thread. It has to complete the execution and then JVM will shut down the thread. Okay, so that's where if you want to restart and all, then you have to go for a wait and notify method, right? Not the stop method, right? Yeah.
Yes.
So there is no, so that is the main purpose. They made it as a deprecated. Okay. So we have seen, okay, what is the difference between synchronized versus lock? Why we can go for
method, we can control only one time. If I have requirement, like if I want to do synchronization, one method, and I want to release the lock into another method, such a cases, we can go for the lock.
Yeah, acquire the lock across methods is not possible in synchronization, right? Okay, and what else? Fair lock and unfair lock, correct? Is also not possible in synchronization, right? Okay, and whether you have it
cannot be cannot any waiting thread. It can invoke any waiting thread, but it will not be like a
the sequence. Most waiting, the thread which is most waiting for a long time should be given the access. You cannot do that. Is nothing but a fair lock or unfair lock is not present in the synchronization. And there is one thing. So can you check whether the lock is present or not? No, in the synchronization. Try lock functionality is not present, right?
Yes.
What is a try lock?
It will check the lock is available or not. If it lock is there, it won't do. If not there, it will go else lock and use the lock.
Yeah. So if the lock is so what is the output of a try lock is, instead of calling a lock method or synchronized block, what I will do, I will call the try lock method. It will acquire the lock. if there is no lock, and then it will return true. And if there is a lock, it will return false, correct? So that means I have some mechanism whether to check whether the lock is present or not. But in the synchronization, do I have that? No, that is a problem. Okay. Now these are the differences why we go for a lock interface. So we already have seen read, write lock, reintent lock, right? And then some program related questions. See, write a program to create a starting a new thread. So just override the run method and call the start method. Write a program to create thread using runnable interface. So whenever I'm implementing a runnable interface, how can I create a thread object?
Creating a thread class constructor, we have to pass the runnable object or runnable implementation class.
Pass the object of runnable interface. Or yeah, when I say runnable interface means implemented class, correct? Or you have to create new runnable anonymous inner class, correct?
Yes.
Yeah. That means object of class which implements runnable interface. Okay. Write a program to demonstrate concept of synchronization in Java. Did we do this?
Yes, sir. By adding the synchronization keyword.
Yeah. So I will say, can I say refer to the program? So refer to the
HDFC
package.
Bank.
Yeah. So can I say I will say that refer to this package, correct? In this package, whatever the programs are there, those are belongs to the synchronization, right? Okay. Write a program to prevent a race condition. Can I say that prevent a race condition is also same as synchronization? Why did I put this question is because suddenly you do not know what is a race condition. Race condition is nothing but one variable is trying to accessed by multiple threads, so there is no consistency. In order to provide consistency, atomic integer or lock or synchronize keyword. Okay. Write a program to demonstrate use of wait, notify all. So can I say this is also under this only synchronization? Or do we create separately? Let's see. Where it is. Yeah. So in this package. Okay. Write a program to demonstrate use of synchronized keyword. So it is already same thing. Okay. Let me remove this. Write a program to demonstrate deadlock. Did we do?
Yes, sir. We have done deadlock package.
So where is the deadlock? Yeah.
Deadlock.
Yeah. In this one, deadlock. See, this program will solve the deadlock problem, correct? How can I solve the deadlock?
We have to pass the same order, sir.
So whenever you are acquiring the lock across the threads, the lock that you are acquiring should be in the same order of correct? Same order you need to give, like synchronized lock 1, lock 2, lock 3, etc. Same order. What is the other way? You can use semaphore.acquire, semaphore.release, correct? Yeah. Write a program to implement producer consumer problem. Yeah. This is main implementation, right? So producer consumer problem is what it uses internally? No, not synchronization. Yeah, it uses a blocking queue. In the blocking queue, which methods will provide the blocking operation?
Put method and take method.
Yeah. What does the put method will do?
It will store the data.
And what does the take method will do?
Means it will remove the first element.
Yeah. So if, for example, if my size is 3 and if I'm trying to add 4th element, what happens?
The 4th element will wait because of the queue is not empty.
No, 4th element will not wait. The entire object, the addition will, that operation will go on wait mode because the queue is already full, and it is waiting for what? On the same object to delete some other thread should to perform the take operation, correct? So whenever some other thread performs the take operation, one element will be deleted and the place will become free, and the new element that is waiting can be added, right? So this producer consumer problem is very important.
Sir, actually, what is the producer consumer problem?
So whenever you say producer here, if you take the Uber, so let us continue the same example to the Uber. So in the Uber, whenever you are booking a cab, what do? You will trying to click a button of book cab button.
Yes.
So then what happens? All your within 2 or 3 kilometers, all the drivers will be notified. Correct? If all the drivers are busy, that means can I say that you are trying to add a data to the queue, but queue is already full? Then is it giving you the error? Whenever so your Uber will say that it's taking time, but will it give you the error? No. So that means it is checking another 1 minute or 2 minutes. If any of the driver is free, immediately your request will be booked. Correct?
Yes, yes.
That means who is the producer in this one? You. And who is the consumer? Driver. Correct?
Driver.
So the same example, if I'm adding, if your queue is full, you are putting a request. Can you say that that is going on to a wait until some other thread on the same object has to call take method? Correct? Here, if the driver is completing any ride, so then he will be busy. Immediately he can take you the data. Correct? So that means you are considered as a producer and the driver is considered as a consumer. So generally in the producer consumer problem, this blocking queue will be used. Anywhere, producer means produce a message, consumer means consumer a message, consuming a message. Okay.
I understand.
Yeah, thanks guys. So guys, tomorrow we are going to discuss this difference between optimistic and pessimistic, and there is one more thing called thread groups. I forgot. So I will explain. I thought of explaining today. Thread groups is very small topic. We'll cover this today, tomorrow. Okay. So fork join pull, difference between optimistic and pessimistic, thread groups, cyclic barrier, and then this difference between. See, we have a thread interface, runnable. So why to go for when to go for thread, when to go for runnable. So these things we will see tomorrow.
One more point, sir. Like the collection invoke all also we miss, right?
Yeah. That is so that is I will cover. Like whenever I'm explaining the cyclic barrier program and all, right, I have to write the program. So that will be called. And okay.
Yes.
Yeah. So I request you guys to please share the feedback. I have kept a feedback link in the group. Whoever has completed, and I'm thankful for them. So whoever did not do it, please do it. Okay. And tomorrow will be the last class. Once the class is completed, by tomorrow end of the day, I will share the entire program, entire notes, code into one zip document in the portal and as well as in the WhatsApp group. Okay. So we'll talk tomorrow, guys. Thank you all. Thanks for joining. Have a nice day.
Thank you.
Yeah, thank you.